All right, let's get started. A cheat code for security programs. Greetings and salutations. My name is Ochaun Marshall. I code, I teach, I hack. I'm a product security engineer at Google Cloud. And the topic of today, of course, is product security. And before we dive into the nitty gritty, we really need to answer a pretty basic question, and that is why. When engineers talk about security, often we're just jumping into AppSec or PlatSec or some specific vulnerability or some cool control, but often product security is overlooked. And there's some fundamental reasons for that. After all, integrating security engineering into the product lifecycle is pretty difficult. And why go through all that trouble when you can do vulnerability research, pen testing, security operations, and patching, all with talking to as few product managers as possible? We so why is the important question? Why are we doing this? What problem are we trying to solve? And the answer to that question, we need a more holistic view. Focusing solely on the application is all of the threats and all of the risk at lower levels of the stack. And then spreading yourself too thin over an entire platform, often you forget some specificity and some nuance. Product is the answer. Product is where you get the priorities from. Businesses get involved in software to present something useful to the user. And so this talk is for anyone in a software development or security role, whether you're an engineer, product manager, or security professional. I want to share with you some perspective about bringing security into your life. So we'll start by defining product security means versus the other paradigms like AppSec and PlatSec. And then we'll focus in on the core concepts of shifting left, right, up, and down. By the end of this talk, you should be able to pitch a product security program within your organization. So, AppSec is the tip of the iceberg. It focuses on the security of the applications itself, but that's not really sufficient. This overlooks the underlying problems in the platform. And a vulnerability in the platform, regardless of how secure the application on top of it is, still exposes the user to risk. So AppSec is the most visible part of all security work. Beneath the tip of the iceberg lies a vast ecosystem and complex ecosystem. It's product security, but it actually includes everything from the OS it's running on, to the databases, to the network configurations, and to the hardware. So product security is also platform security because a perfectly secure application on a vulnerable platform is still a weak application. And therefore, a comprehensive product security approach means that you're looking beyond just the application. You're embracing a holistic view. And when you do this, of course, you make products more secure. Now platform security. Product is the purpose of the platform. And so when we talk about platform security, it's really tempting to view this as a vast, disjointed collection of assets. Some servers here, some services there, each with its own health checks and uptime. This is technically correct, but the perspective is too broad to actually be useful. Why? Because these systems don't exist for their own sake. They're part of a greater ecology. Again, delivering a product. And that's where we need to refine our thinking. There's a popular principle like treat your servers like cattle, not pets. Now, this is great for building resilient systems, but it's not helpful to say the farm has livestock. The song, "Oh, MacDonald had a farm, E-I-E-I-O, and on that farm he had vertebrates. E-I-E-I, no." It's not helpful to know that old MacDonald has vertebrates. To keep the farm functional, you have to know the difference between chickens and dairy cows. Each have different needs. Each have present different vulnerabilities. Each have different risk and value rewards depending on the farm's operation. And adopting a product centric view helps us do exactly that. It forces us to ask the right questions. Which of all of these systems point processes sensitive user data? Which of all of these systems have key pathways that, if compromised, would have a direct impact on the user's trust? By focusing on the product, you can prioritize our security efforts to apply the most vigorous controls onto the most important parts of the platform. And we need to make these ideas concrete. So we'll turn over to this old standby classic cheat code. You got to memorize? Thumbs twitching a bit? To play the game today, we'll simplify it because some of y'all don't know the directional buttons. So we'll be focusing in on all of the directions here for just the 4: shift left, shift right, shift up, and shift down. Now, shift left is an idea we've heard over and over again. It's a powerful concept. It means moving security into earlier and earlier phases of the development lifecycle, and from being an afterthought into a core consideration. But cloud development is complex. You need more than just one direction. Playing field is multidimensional. We need to look at the whole entire board. So today we'll talk about shifting left, but we'll also talk about shifting right, continuing the security work through production, through active monitoring, robust incident response, and continuous testing of live systems. We'll also shift up, making a security an organizational priority, ensuring that security is part of the strategic conversation and not just a technical one. And then we'll shift down, which is building security into the very foundations of the stack, which is all the way down to the metal. So let's first talk with shifting left. Now, again, it means lots of things to lots of people, but today we're focusing in on integrating it into the product lifecycle. So for the purposes of our discussion, there are 3 foundational building blocks. Product is what the user gets. Straightforward. Systems are assets that the product uses. They're closely tied to the product. So in cloud, these could be things like a Kubernetes cluster, it could be a bucket, and if you're an older enterprise and you have production systems, all those weird quirks about your production environment are also just assets, things that the product can use. Now, the final part is teams, and obviously teams and people are very important, right? Because software still needs people. Yes, we agree. Yes. And so the dreams and visions of product leadership, as well as the realities of being a software engineer, frontline engineer, is really important when you're trying to integrate security into that lifecycle. And every company does it a bit differently. But in general, you can think of the product lifecycle into 4 key phases. Phase 1 is just design. It usually means knowing something about what the users want or need. Phase 2 is experimentation. It may be 1 stage or several stages, but the goal from experimentation is just to get some feedback, some live feedback and quality assurance. Phase 3 is the implementation or build, and phase 4 is the release of the product. Now, there's always new feedback, new things that have to be integrated into the product after the launch. That can be put in the 2.0 version or just the next version. And that's where you can start again with, guess what? Design. And again, this is just a generalization, but it's getting us to start to think about critical queries and critical questions. How and where do we embed our actual security capabilities into this lifecycle? So, of course, the first thing is to make sure you partner at the very beginning. And we could talk about the tools that will help you build that partnership. On the far left, of course, this is threat modeling. Threat modeling is a way you can find weaknesses in the architecture before a single line of code is written. But it also can be used reactively for systems that are already built. You can enhance your threat modeling through targeted threat intelligence. Threat intel shows you how real-world adversaries are targeting products like yours. And with that information, you can design proactive defenses against the most likely threats. And then moving into the build phase, this is what the security reviews come in. They work in parallel with development. The key here is not to think of them as a final exam at the end. Instead, think of them as a continuous partnership, a chance to collaborate and make sure that the design was actually followed and built through securely and correctly, and to look for additional vulnerabilities in the code itself. And then when you find things, then you need to think about remediation. And you need to think systemically. How can we eliminate entire classes of vulnerabilities rather than playing whack-a-mole each and every time? This could mean building better frameworks. This could mean building better libraries or tools that make it easier for all the developers to write secure code by default. Now we shift right. And this is where I remind you that product security just doesn't stop at launch. So there's proactive defense, continuous monitoring, and rapid response in the live environment. So big picture and thinking at scale. A proactive defensive response is different than a traditional one. It's all about securing the product, which is really about keeping the users safe. There are a few ways of thinking about keeping product security constant. As we go through them and we talk about these approaches, what these mean for your teams and how you set them up and how they can collaborate and how individual engineers can actually see their work. First is constant vulnerability research and red teaming. So a standard red team will focus on trying to compromise the platform, but a product-centric red team does a little bit more. So questions that a product-aware red team would say is, can I abuse this feature to get free credits? Or can I manipulate this API to get someone else's data? Their work requires deep product-specific knowledge to uncover risks in a generic platform scan would miss. And the same principle is applied to product-aware monitoring and incident response. Standard monitoring will send alerts on system-level events like high CPU usage. But product-aware monitoring asks the really important question, which is, why is this service account suddenly trying to export 100,000 records at 3 a.m.? Always 3 a.m. And why am I being paged for it? My goodness. Incident response isn't about isolating a single machine. It's about understanding the immediate impact and the product and the user responding for that. And one great approach across the industry is partnering with external researchers. When you look, you can look, once a researcher submits a bug or presents to you a risk, you can look more to the not only the technical flaw, but you can look through the lens of the product and its users. That's how we can assess real-world risk. That is how we can get precise decisions about how to prioritize that fix, the staff it needs, and other resource considerations. And there's a more immediate way of thinking about shift right too. And this is one of the things that you think about, the first thing that pretty much everyone really learns to do, where we actually file tickets with the reports. So on the left, you have your normal security activity. It doesn't matter what the person behind the keyboard's doing. It could be a pen test. It could be a design review. It could be code audit. It could be firing up a fuzzer. Does not matter. If the only thing at the end of it is just a report, that's terrible, because the report is then a PDF that gets chucked over the fence, and then trickles down the org chart. Sometimes that process takes 6 months to the year, depending on how big the enterprise is. And that's not great. It's just not. On the right, we have a better approach and a better way of thinking about it, making it consumable by both executives and engineers. File a bug with the report. Make it actionable so that executives and engineers can work on it and take action. Engineers speak in the language of bugs and pull requests, not reports and documents. And of course, you still have to write the report. I can't save you from writing the report. But it's important to point out the flaws in the engineering context as well. You can go further, faster if you shift right, and the key takeaways for engineers to consume and act on. Now, hacker in the boardroom. Let's talk about shifting up. So we talked about shifting left and shifting right. The next part of the cheat code is shifting up. And this is the concept of escalation, making it absolutely critical for a healthy security culture. Escalation is a normal, healthy security process. I'll say this again. Escalation is a normal, healthy part of the security process. It shouldn't be seen as a failure or some disruption into the business as usual activity. It is not about getting someone in trouble. Escalating is just a formal mechanism for getting the right people involved. All right. And that links up with the second point. Security benefits from active management support. So a grassroots security effort where passionate individuals just work day and night is just not sustainable. Good security does not rely on heroics. And so shifting up means escaping the myth that leadership doesn't have to be involved. You need to put them in a position to do what the leaders and what the managers do best. Prioritize resources, make difficult trade-offs between features and security work, and unblock cross-team dependencies. The active support that you can get with management can be a game changer. And what I'm saying is that think of escalating as a way of just addressing the complex issues. When you escalate a security issue, you bring leaders with the scope and authority to align the resources across your organization and to allocate the resources to tackle that problem systemically. So shifting up is about treating security as a strategic issue. It involves getting the right people working on the right priorities. And that's how we move from a state of constant noise and panic to an overwhelm to a respected product security program. Finally, we shift down. And now pointing out that product security is a full stack engineering discipline. Circling back on the earlier iceberg discussion, when we focus on the product, we have to consider every layer of technology that the product is built on. So in the cloud, that means the security spans from the initial user request, the gRPC call, HTTP request, all the way down to the silicon that it runs on. And what I mean by shifting down, it's extending our security focus to the entire technology stack. So in the blue and the upper parts, that is the land of the application, the land of OWASP top 10, and where many teams focus a lot of their efforts because it's the most visible part. But then we need to move down to the operating system and the kernel. There, like a single vulnerability, like a container escape, can undermine every control in the layer above it. And then we must shift all the way down to the firmware and hardware. And this is the lowest layer where the most dangerous threats lie. So imagine this hypothetical scenario for me. An attacker who can compromise the firmware can install a persistent boot bootkit that survives reboots and is nearly impossible to detect. And now to tie this all back to the beginning, all the layers mean shifting down are also a part of shifting left. So when you're doing your threat assessment, when you're doing your risk assessments and your threat model, your threat intel, all of it has to take into account the entire stack. That from everything from the kernel to third-party hardware to the application that sits on top. And of course, we can go into each of them and like really dive into how the risk assessment piles on, but that's a really deep dive that we'll save for another talk. And now that I've given you like the directional buttons, at least for the cheat code, I've shared with you some approaches that you can think about when you build your security programs. But if you remember one thing from today's presentation, boring security is beautiful. And now that sounds counterintuitive, but it's not about making security uninteresting. It's about preventing the heroics, the last-minute firefighting, the moving toward a system that's resilient by default. And when you make your security program boring, it becomes more beautiful. Automate security checks and tasks. Human-led reviews are essential for a security program, but they do not scale for thousands of code changes that happen in the product world every day. Sometimes, depending on where you're at, thousands of product changes every hour. You can, by automating some of the security checks for the common vulnerabilities, you can make the platform do the heavy lifting for you. This provides constant, immediate feedback and frees up your security engineers to focus harder on the more strategic challenges than the routine tasks. Then you integrate security seamlessly into developer workflows. Automation is only effective, it is easy to use. You cannot expect developers to constantly context switch between a separate dashboard to run a complex tool. Instead, meet them where they already are. Build security checks directly into the code repositories, their CI/CD pipelines, their IDEs. When security feels like just another helpful linter, it actually gets used. Make sure the secure path is the path of resistance. Also, be selective with which controls that you implement. Like, I've had talk in a previous life, and when I was consulting, I've talked with people who said, hey, we want to make sure we do a code scan, a static analysis that takes 10 minutes, and a CI/CD pipeline where efficiency was measured in seconds. There's a place for that static analysis code scan. It's not immediately before every code push. Finally, we need to make security a shared responsibility because it is shared fate. Google talks a lot about shared fate. And I'll oversimplify all of that just to say when security is automated and when it is integrated, it stops being the exclusive domain of a small security team. It becomes a natural part of everyone's job. When everyone has a stake in the outcome and is empowered to contribute, security becomes from boring to beautifully effective part of your engineering culture. And so we've been talking about cheat code for security. It's not a shortcut, but it's a fundamental shift in perspective. We get stuck on the AppSec side, which is just the tip of the iceberg, but the real risks lie deeper. The cheat code is part of a 4-part framework. And first, of course, shift left. We need to think about security from the very beginning of the development lifecycle. Think of threat modeling during design. Why? Because it's cheaper and easier to fix flaws early. Then we shift right. Security doesn't stop at launch. We need proactive monitoring and incident response because the threat landscape is always changing. Security is a continuous loop. Third, we shift up. We need to elevate the conversation. Security is a business risk, not a technical one. This means buy-in from leadership and making security a strategic priority. And then finally, we shift down. You must secure the entire stack. A holistic application from a secure application on a vulnerable platform is still at risk. So we need a holistic view of the technology. So shift left, right, up, and down. And together we create a security program that's more integrated and more predictable, beautiful, and boring. Boring means it's working. It's a well-oiled machine and not a constant fire drill. And that's the call to action. Take this framework, ask the right questions, ask, are we shifting in the right directions with this activity? This will help you build a security program that is both secure and resilient. Thank you for your time. The question was, do I find any risk frameworks particularly useful for this approach? And one I will recommend is Rapid Risk Assessment Framework. So go like RRA Rocks. It's open source. It's publicly available. If you're just like getting started and you need to quickly identify risk, that's a good place to start. And if you have compliance, the great things about that particular framework in general is that if you have a compliance component, they're easy plugins based on that. Excellent question. Next one. What do you do to get leadership buy-in on this approach and shifting in all the directions? And so I'll surface this. And what the question was is like, how do you get leadership buy-in on this approach? And the simplest answer is product. Like product is the answer. And what business case that you can make in your organization is like, hey, we have a list of products. We have a comprehensive inventory of these products. These products are the most revenue impacting. These products are like their users really love and really crave. And if something happens for these products, it hits the bottom line harder than for these other products. Doesn't mean you neglect those other products. It just means you you switch and focus intensity. All right. Anything else? So question was, when you're shifting down, how do you keep from squirreling and rabbit hole and like good scoping from the beginning of the engagement? That's the answer. When you're focusing on the threat model for product foo, for example, the product team for foo has explicit and granular controls for certain of their assets than others. So there's an easy way of doing this. It's like for the asset and the system-based part of the product security review, you're looking for misconfigurations. If the risk is inherent if it's a subproduct and the risk is inherent to that subproduct, that risk belongs more in the threat model for a product bar than it does for product foo. Does that make sense? All right. No?
Okay. So let's say I don't work for a big company. I work for a small company and I only have, I guess, the resources to shift in one direction. Which direction are you going?
I challenge that. The question is like, if you're a smaller company, do you only have resources to shift in one direction? And I do challenge that. And I challenge that assumption. Like, if you are a one-person shop, shifting up and down is within yourself. Like, if you're in a two-person startup with like a business-led founder and a technical founder, escalation procedures are easy. You're sitting in an apartment in the Bay Area eating ramen, staring probably at the same monitor together. So you just nudge, and it's like, hey, I think this is a problem. You talk to your co-founders like, hey, I think this is a problem. I don't think we could raise funding this way. Like, so it doesn't matter how big or how small, you can shift in all the directions.
Shifting up require a financial assessment of the risk, or are there ways to bring a more generic security focus from our technical side to that discussion?
The question was, does there need to be like quantitative financial analysis for every escalation? And the answer is it depends. And I'm going to steal from my old consulting job and say it depends. At certain levels of escalation, it will be more efficient if you can provide that information and get that quantitative analysis. But you can also just speak to it just from technical hazard and technical risk of systems. When it doesn't always have to tie into a dollar amount. And if your escalation procedures in your organization are structured enough, escalation level 0, you just talk shop and you do the technical. As it's going up and as it's getting prepared for higher and higher audience, collaborators will come into it and will make that quantitative analysis easier. And if that is what is needed to really make the case for that escalation. Excellent question.
What do you do when there's pushback between the security team and the product team around the impact of a finding, or hey, I think this is critical because our business can go down. They come back, hey, our business hasn't gone down yet, so clearly it's not that critical.
So the question is like dispute resolution between security and product, like is a critical really a critical? And you can stand firm on the technical parts of your assessment. Like, does every finding mean that the entire business goes down? No. It does not make business easier. Why would we continue to operate in this? Why would we continue to operate with this anchor around our, like, with this ball and chain around our neck? Like, it doesn't make sense. This is preventable risk. And this is preventable risk. And most of the time when you're highlighting it, it is. Business is impossible to remove all risk from business. So really assuming that the person that you're acting with is holistically motivated, you can have the discussion of risk levels and like, okay, crit versus high versus medium, all of that. But is moving forward an acceptable amount of risk with this, whether it's this product launch, whether it's a new feature, all of that. Make sense? Yeah. Going once. All right. Woo!